Alright, this week's lesson is solving equations using algebra. Our goal this week is to solve a given problem using linear equation and then to verify the solution using the method of substitution. Your resources this week are the video that you're watching right now, and there are 3 different links to different videos for extra explanation on this. And for extra practice, you can use your math workbooks 6.1 and 6.2. So we're going to start by reviewing this concept. This is something that you did last year as well, and something that you use in everyday life. So let's explore and review the math. If a blizzard costs $5 and I have 20, how many blizzards can I buy? Most of you probably can automatically say 4 blizzards, okay? That you just did algebra right there. So don't be afraid of the word algebra. I know some of you get really scared when we start saying we're gonna start algebra, but it's something that you use all the time, just written in a math format. So let's rewrite the above situation in a math sentence. We have $5, wondering how many blizzards we can buy, and that total can only be $20 because that's how much I have. Okay. Remember, when we write 5x side by side like this, we're saying we're multiplying 5 and x together. Okay. We just won't write it like 5 times x like this, because then we have 2 x's and it makes it really confusing. That's why instead of doing this, we just write them side by side like this. Okay. Or you can use a dot in the middle to show that you're multiplying the two things. All right, how do you get to your answer? If I have 5x is equal to 20, how do you get to the 4? I want you to pause the video and write down your answers right over here. All right, let's see how we can show our work algebraically. We start with our equation, which is 5x is equal to 20. Okay, and you would have noticed that we had to divide by 5 to get to our answer of 4. 5 cancels out, and 20 divided by 5 gives us 4. Okay. All right, let's then look at the next part of this. What operation did we use? We used division. What operation was in the question? 5 times x is equal to 20. So in the question we had multiplication. Okay, what do we know about division and multiplication? These guys are opposite operations. So when we're solving for unknowns in a linear equation, we're going to be using opposite operations to undo the equation. Okay. Lastly, how can we be sure that this is correct? Okay, so our original equation was 5x is equal to 20. And we said that x must be equal to 4. We can verify this by substituting in 4 for x. So in place of x, I'm going to place the 4. So 5 times 4 is equal to 20. And let's verify. 5 times 4 is 20. So 20 equals 20. That is true. So that means we got this question correct. Okay. So for all of your questions that you'll be solving for this unit, you should be able to tell if you got your question right or wrong. Okay. If you're verifying it correctly. If in the process of verification you get 2 different numbers on both sides, that means your answer must be incorrect, and you would just go back to see where you made the mistake. Okay. All right, next we're gonna use a diagram to model the situation. Okay, looking at the diagram above, what is S equal to? In this diagram, we have a balance, and the balance, the top part here, right, is straight, meaning both sides have equal weights. Okay, so this side must equal this side. Okay, what would you normally do to get what S is equal to? Okay, because we're trying to get what S is equal to, you want to see what 1S is equal to. So we can maybe do that by taking out 5 little red squares on this side, and in order to keep the balance equal, I need to take away 5 little squares on this side as well. If I do that, I'm left with 2 S's on this side, and I have 3 times 4, 12, 13, 14 little red squares over here. Okay, if I have 2 S's on this side and 14 red squares on the other side, and those 2 sides are equal, then 1S must equal 7 red squares. Okay. All right, let's write this in a math sentence. So we had on the left side 2 s's plus 5 red little squares. And on our right side, we had a total of 19 red squares before we crossed them out. Okay. Now to solve this algebraically, we had to do the opposite operation. But in this case, okay, we have a multiplication because we have 2 times s, and we have an addition. Which one should we do first? Well, going back to our diagram, what did we do first? We first took away 5 red squares on both sides. So we actually did subtraction first. So we're going to subtract 5 on both sides. Okay, because that's what we did first when we used the model. So take away 5 on both sides. And I'm left with 2s is equal to 19 minus 5, which is 14. Okay. Just going to continue this right here. So we had 2s is equal to 14. Okay, now what do I need to do to isolate for s? Right now the 2 and the s are getting multiplied together. So I'm going to do the opposite operation, which is to divide by 2, divide by 2. If I do that, the 2 cancels out. S is equal to 7. And that's the answer we got over here as well. Okay. All right. What operation do we first use? We actually use subtraction first. Subtraction. What operations were in the question? In the question, we had multiplication and addition. And we ended up solving this by doing subtraction first, and then we did division. So opposite operations to multiplication and addition. Okay? So do you guys remember when we did order of operations when we're solving the equation? Okay, when we're solving an equation, we have to follow the acronym BEDMAS. Okay, so let's go down here. When solving operations, we used BEDMAS. This was order of operation. Okay. Right now we are almost we can say that we are undoing the operation here. We're undoing the equation to solve for an unknown. Because we are undoing the equation to solve for unknown, we're going to use the opposite of BEDMAS, which is Sam and Deb. Okay, according to Sam and Deb, we need to subtract and add first, multiply, and then multiply and divide, and then deal with the exponents and brackets, but we won't get to this yet. Okay, all right. So going back to this, according to Sam and Deb, we used subtraction first, and then we used division to solve our equation. Okay, we're using BEDMAS, but the other way around because we are undoing the operation. We're going to undo this one to solve for our variable. Okay, lastly, before we say we have our final answer, we need to verify. Okay, so our original equation was 2s plus 5. Oh, sorry, let's write this again. 2s plus 5 is equal to 19. And our answer, we said s is equal to 7. We're going to substitute an s for 7. Okay, 7 for s, sorry. If we do that, we get 2 times 7 plus 5 is equal to 19. In this case, guys, we are actually solving the equation, so we're going to follow BEDMAS and do the multiplication first. Okay, so 2 times 7 is 14 plus 5 is equal to 19. The 19 doesn't change, okay, because we're not doing anything to this side. Okay, and on this side, we have 19 is equal to 19. They are equal, so this is correct. Our answer must be correct. Okay, all right, so let's apply what we just went over to some examples, okay? The main ideas I want you to take away are, what we're doing when we're solving equations using algebra, we're isolating the variable. We isolated for s over here to solve for what s is. And we're going to do opposite operations, and when we do the opposite operations, we're going to apply it on both sides. See how we took away 5 on both sides, divided by 2 on both sides, always apply the operations on both sides to keep the balance. Going back to our diagram, to keep the balance balanced, okay? We want both sides to stay equal, okay? And then lastly, I want you to verify your solution because it's an easy way to check if you got the question right or wrong, okay? All right, let's move on to our examples. Solve the following equation using algebra, then verify your solution. Show your work, okay? On the side here, I'm just gonna write Sam and Deb because that's the order that we need to do our operations, okay? So we have to do subtraction, addition, and then multiplication and division when we are solving for a variable, okay? So first one, we have 4y is equal to 16. 4 and the y are getting multiplied together, so I'm going to do the opposite, which is to divide. Gets rid of that. Y is equal to 16 divided by 4, which is 4. I'm not done because I need to verify, okay? So in place of y, I'm going to place the 4. That's equal to 16. 16 is equal to 16. So this one I can say, yes, my answer is correct. All right, this one, 100.x. Okay, I just put this over here to show you that you can use a dot to show multiplication. So here we are multiplying, so we're going to do the opposite by dividing both sides by 100. X is equal to 2. We're not done because we have to verify. We go 100 times, and in place of x, I'm going to put 2 is equal to 200, and 100 times 2 gives us 200. So this one, again, we can say is good. All right, next one. X minus 10 is equal to 15. We are doing subtraction. We're going to do the opposite operation and add 15. Sometimes I like to draw a line in the middle like this to keep my work organized. Okay. Oh, I need to write these again. I'm not adding 15 to both sides because I'm trying to isolate for x. I need to get rid of the 10, so I need to add 10 to both sides. Okay. Let's get rid of the 10 because negative 10 plus 10 is equal to 0. That cancels it out. X is equal to 25. Okay, let's verify our solution by putting 25 in for x. So 25 minus 10 is equal to 15. 25 minus 10 is 15. So this verified. It worked. All right, let's try the next one. This one, we now have 20 minus z is equal to 5. Okay, looking at the operation that we have in this question is subtraction. Okay, so then let's try doing the opposite operation, addition. What do I have to add? Right now, the z is getting subtracted, so I'm going to add z on both sides. Then if I do that, I have 20 left on the left side, and I have 5 plus z on the other side. Does this mean that I subtract z on both sides now? If I do that, I'll end up just adding z on both sides, subtracting z on both sides, and I'll never get to my answer. Our goal is to isolate for z. I want z by itself. So the number we actually have to get rid of is the 5. Okay? 5 plus z is the same thing as z plus 5 because 1 plus 2 is the same thing as 2 plus 1, right? So if I were to rewrite this as z plus 5, then it's pretty clear that we need to take away 5 on both sides. Then I get 15 is equal to z. Okay? I could rearrange because it was an addition problem. I can't do it if it's subtraction. So going back to 20 minus z, I can't. This is not equal to z minus 20. Because if you look, 12 minus 10 does not equal 10 minus 12. This one is 2. This side is negative 2. So you can't switch around a subtraction like this one, but you can switch it around if it's an addition. Okay? If you want to learn how to do this one by dividing and multiplying by -1, come to our Google Meets on Friday. All right, am I done with that question? No, not yet, because I need to verify my solution. Okay, so I have to go, okay, is 20 minus z, which we said was 15, equal to 5? 20 minus 15 is 5, and that's equal to 5. Yes, this is correct. Our answer is correct. Okay. Last two questions have two operations involved. Okay, this is when Sam and Deb are gonna come in handy. Okay, so this one we have 2 times x plus 5 is equal to 11. So we have a multiplication and an addition. According to Sam and Deb, we're gonna deal with the addition first. Okay, so opposite operation to addition is subtraction. So I'm gonna take away 5 on both sides. This cancels out. 2x is equal to 11 minus 5, which is 6. And then right now 2 and the x are getting multiplied. So I'm going to do the opposite operation and divide by 2. Then x is equal to 6 divided by 2, which is 3. I'm just going to verify my solution on this side. 2 times, instead of x, I'm going to use 3 because that's what we got for x. Plus 5 is 11. 2 times 3 is 6. Plus 5 is 11. Is 6 plus 5 11? Yes, it is. And we keep the right side the same, okay? This works, so that means this question is correct, okay? All right, last one. Almost there, guys. Okay, again, we're going to draw a line to keep my work organized. This one, I have negative 2 times s plus 7 is equal to 27, okay? Again, I have a multiplication. I have a multiplication and addition. Okay, I'm going to deal with addition first because that's what Sam and Deb tells us to do. Okay, so I'm going to get rid of the 7 by doing the opposite operation, which is subtraction. So take away 7. 7 minus 7 is 0, so that cancels out, and I'm left with negative 2s. And that's equal to 20 right now. Okay, now we are isolating for s, so what I need to get rid of is negative 2, not just the 2, but negative 2. So I'm going to divide both sides by negative 2. Negative 2 divided by negative 2 is 1, so it cancels out. And I'm left with just s on this side. 20 divided by negative 2 is negative 10, because positive divided by a negative is a negative. Okay, see how we have to relate back to working with integers. Okay, all right, I have what my s is now. I'm gonna lastly verify my solution by putting in negative 10 as s. So I have negative 2 times negative 10 plus 7, and this has to equal 27 for my answer to be correct. Negative 2 times negative 10 gives me a positive 20, because negative times a negative is positive, plus 7, and on my right side the 27 stays the same. 20 plus 7 is 27, and on my right side I have 27 as well. That means this is correct, and s is indeed equal to negative 10. Okay, I hope this helps. Okay, use these examples as a reference when you're doing your week 6 task 1. Okay, just as a clarification here, a note: x is a variable. It's a variable is a letter that represents an unknown number. So we're solving for that unknown number. Okay, therefore it doesn't always have to be x. It can be a j, a p, a k. You get the idea. Okay, but x is the most commonly used variable here. Okay, that's why hence if we go back to some of our questions, sometimes it's asking us to solve for y, a z, an s. Okay, if you have any questions, always email us. Okay, and come join our Google Meets to go over some challenging questions that could come up in this unit.